Hey there, welcome to Tech World GBA, your go-to channel for all things tech. If you love staying updated with the latest in technology gadgets and tutorials, you're in the right place. Let's delve deeper into the types of session management in web applications, with examples and more details. Cookie-based session management, how it works. When a user logs in, the server generates a unique session ID and stores it in a cookie on the user's browser. For subsequent requests, the browser automatically sends the cookie back to the server for verification. An example: online shopping carts often use cookies to track session information. Even if a user navigates away from the site and returns, the cart items remain because the cookie identifies the session. Security tips: use the flag to prevent JavaScript access to cookies, reducing XSS attack risks. Apply the flag to ensure cookies are only sent over HTTPS. Server-side session management. Details. Here, session data is stored on the server, often in a file, database, or memory. The client holds only a reference, usually a session ID, in a cookie. An example: PHP and other frameworks use server-side sessions where the variable holds user data like login status. Pros and cons. Pros: reduces risk of exposing session data since it's not stored client-side. Cons: the server needs to manage session storage, which can impact scalability. Load balancing requires special handling to ensure the same server handles consecutive requests, known as sticky sessions, or a shared session storage is used. Token-based session management, also known as JWT. Overview: JSON Web Tokens contain encrypted or encoded data and are sent to the client after successful authentication. They are included in headers, for example, for API calls. An example: single-page applications, or SPAs, often use JWTs for session handling. After login, the client receives a JWT that allows seamless API interactions. Pros: stateless. The server does not need to store session information, making it highly scalable. Portable tokens can be passed between different services in a microservice architecture. Cons: token revocation is challenging as JWTs are stateless. It may involve using a blacklist or token expiration strategies. Storing tokens securely on the client, for example, in or cookies, must be handled carefully to prevent XSS attacks. Alright, let's dive into database-backed session management. Here, session data is stored in a relational or NoSQL database. This approach allows for persistence beyond server restarts, which is pretty handy. For instance, applications that need robust data recovery often use this method. Think about user preferences or game states in gaming apps. They might be stored this way. Now let's talk about the advantages. First, it's durable. Sessions persist even through server failures, which is a big plus. Secondly, it allows for centralized management across multiple servers. But of course, there are some drawbacks. This method may increase latency due to database calls, and it can be more complex to implement and manage replication for large-scale use. Moving on, we have in-memory session management, such as using Redis. In this setup, data is kept in RAM using in-memory data stores like Redis or memcached for fast access. This is especially popular in real-time applications due to its speed. For example, chat applications often use Redis to store active user sessions for quick retrieval and interaction. Now let's look at the pros. It's extremely fast due to RAM access, and it supports high concurrency, which is great. However, there are some cons to consider. By default, it's volatile, meaning data is lost if the server restarts unless configured for persistence. Plus, it's limited by the available memory size. ###6 Client-side session storage. Modern browsers allow storage in or where data persists for the session duration or across browser restarts respectively. A web app can save a JWT or temporary state data in to keep the user logged in until the browser is closed. Pros include reducing server load since data is stored client-side and being simple to implement. However, there are cons, such as data exposure risk if not encrypted properly, and vulnerability to client-side attacks like XSS if security measures aren't in place. ###7 Hybrid approaches. This concept combines client and server strategies. For instance, using cookies to store JWTs for stateless validation alongside server-side checks for sensitive operations. An example of this would be banking apps, which might use tokens for session management but validate against server-side checks for every transaction. The benefits include enhanced flexibility, balancing client-side speed, and server-side control. Best practices across all types. Implement timeouts by using both idle, meaning inactivity, and absolute timeouts to end sessions automatically after a certain period. Always transmit tokens and cookies over HTTPS to protect against interception. Encrypt JWTs or other tokens to prevent exposure of sensitive data. Use vetted libraries for session management to reduce the risk of vulnerabilities due to custom implementations. These strategies are chosen based on the specific needs of an application, balancing scalability, security, and user experience. Don't forget to subscribe to the channel and hit the notification bell so you never miss out on any of our informative videos. And if you enjoyed this video, make sure to like, share, and leave a comment below. We'd love to hear from you.